If you're just getting interested in CNC routers and trying to learn about them, but finding yourself more and more confused, you should not have to be digging through 100 videos just to learn about these machines. By the time you're done with this video, you're gonna know more about CNC routers than most people do after they buy their machines. And that, my friend, is a promise. IDCwoodcraft.com. Hello, my new CNC router friend. I am Garrett from a CNC expert and the owner of IDC Woodcraft. You know, the company that provides you with the premium CNC router bits to carve out your amazing CNC projects. I know that being a brand new green beginner can be so overwhelming and confusing when it comes to learning about CNC routers. So this video is designed for you as someone who doesn't understand what these are, what they do, and you're definitely interested in all that amazing stuff that people are creating. And you want to learn more about it because there's a part of you that wants to get one of these things, but you got to understand it first. So this video is designed to save you a ton of time by taking you from the 29,000 foot altitude bird's eye view of looking at a CNC router, and we are going to start coming closer and closer into these machines. Basically, I'm going to pick these things apart so you understand everything about a CNC router. Everything from its construction and how it works to the entire process flow. And by the time you're done with this video, you're going to understand a lot of things that people are talking about in other videos, the terminology and the processes. You're going to have so much more confidence when it comes to learning about these and eventually picking out your CNC router for your shop. So here's how we're going to go. We're going to start right at 29,000 feet, the bird's eye view, and I'm going to bring you down nice and close to these machines. We're going to start right off at the top with the number one question that I get asked. One of the very first questions I get when it comes to brand new CNC creators is, what the heck does CNC stand for? Well, CNC stands for Computer Numeric Control. At the very basic level, what that means is a computer sends the signals to a machine that moves around, and it tells it exactly how to move at different points in its motion. Think of it like this, a GPS. So for someone like me, I want to go to some location that I don't know how to get to. So I get in my car and I say, GPS, navigate me to address XYZ. Now, I'm as stupid as the machine is. I need a computer to tell me exactly what to do. So my job is to follow the instructions that the computer or the GPS gives to me to navigate to the destination. And technically what I should be doing when it comes to CNC is I should follow every speed limit exactly. I should stop at every stop sign, you know, not those optional stop signs. Be very specific with exactly what the computer or the GPS is sending me. That's essentially kind of like what CNC is, with a little bit of a caveat. Now, GPS will make corrections for you as you move along. The computer that's running your machine is not going to make corrections along the way. Your CNC router is being told to move around by a computer, but that computer is also following a very specific set of instructions that do not change. Those instructions are called G-code, which we will get into later. For all intents and purposes, that's what CNC is. It's a computer that has a set of instructions, it sends it to the machine, and it tells the motors of the machine how to move, how fast to move, so the machine does all its stuff the way it's supposed to do it. My friend, your CNC router is dumber than a box of rocks, and it's going to do exactly what the computer tells it to do. Nothing more, nothing less, and those set of instructions will not change that you put into the computer until you change them. That's what CNC stands for, Computer Numeric Control, a computer that's telling the machine what to do. Now you understand that a CNC machine is a machine that moves around in space by getting instructions from a computer. With that in mind, what makes a CNC router? Because there are other CNC machines out there. A 3D printer or a plasma cutter, water jet machines, a CNC lathe, CNC milling machine. There's a ton of CNC machines. So a CNC router is a CNC router because of several factors. Number one, it is a very high-speed spindle machine. In other words, this spindle can turn up to 30,000 RPMs in some cases, even higher. The one I have here goes up to 24,000 RPMs. The reason we want a spindle to turn that fast is because of the materials it can work through and how fast it can work through them. So a CNC router is designed to cut softer materials, plastic, wood. In some cases, brass or aluminum, like the Altmill CNC router here. It is strong enough to handle brass and aluminum once you get used to it. But a CNC router cannot handle harder materials like steel or brick or granite because it simply doesn't have the girth. It's not built to handle the workload that these hard materials are designed for. Let me give you a little comparison when it comes to machines like CNC routers that can cut softer materials like wood and plastic, phenolic and what have you, and then the machines that can cut harder materials like steel. So this is me in my normal body build, not too bad. So with that body build, I can cut the softer materials like wood and plastic. But if I'm going to be cutting steel, I've got to look like this. I have to have the Arnold Schwarzenegger build. This is the type of girth I'm talking about when it comes to a machine that can cut the harder materials. If you want to cut steel and stuff like that on a CNC router, don't do it. They're not built for it. And the spindle turns way too fast to be cutting those harder materials. To give you an example of what I mean by that, this spindle is designed to go from 10,000 RPMs to 24,000 RPMs. When you're cutting steel, you don't want to go faster than maybe 2 to 3 to 4,000 RPMs, depending on the cutting tool that you're using on the end. So a CNC router is not designed to handle that stuff because of the spindle and because it's not designed with the bulk to handle hard materials like that. A CNC router technically is a machine that makes contact with the wood with a cutting tool called a CNC router bit, which we will get into the basics of CNC router bits a little bit later. But it makes contact with that material and it moves around to remove that material. Whereas with a plasma cutter, it's not actually making contact with the material. It's burning or melting the metal away through an electric current going through into the material, heating it up really fast. A water jet is using water with at very high pressures with abrasives in it to cut through metals like steel. The 3D printer is adding material to create something. So the CNC router makes contact with the material, it moves through the material with a rotating cutting tool, and it removes that material as it's moving around. CNC routers, in your case, is going to be a 3-axis machine. And what that means is it travels around 3 axes in space. So you have your x-axis, which is always left and right relative to the front of the machine. And so from your perspective, watching this video, you are standing in front of the Altmill. So this is left and right. That's the positive direction going to the right. This is negative direction going to the left when this carriage moves back and forth. Then there's the y-axis. The y-axis is the travel back and forth. So this whole contraption here is called the gantry. And the gantry is moving along the y-axis. So when the y-axis or the gantry is moving towards you, it's moving in the negative direction. And when it's moving away from you, it is going in the positive direction. This contraption here is called the Z carriage. You won't hear that term very much in CNC routing, but technically it's a carriage, carries your spindle. And it has all the components for the Z travel, which is up and down. So Z minus is always down and Z plus is always up. So we have this 3-axis machine that can move side to side, back and forth, and up and down. And that computer that's sending the signal to this machine, or signals, is sending signals to basically 3 different motion areas. The Z motor, which this motor right here, it's called a stepper motor. I'll talk about that in a minute when I start talking about the components of the machine. It's sending a signal to this motor to move it up and down. At the same time, it's sending a signal to the X motor, which is moving it back and forth. So now you have 2 motions that are being sent from the computer to the machine. And with these 2 motions, now we can move back and forth, or left and right, and up and down at the same time. So we can get this kind of motion along the whole thing. And then it's also sending a signal at the same time of the Y travel. So now not only are we getting it side to side like that, because we're having X and Z travel, but we also have the Y travel. So now we can do it kind of like that. So we're getting motion in 3 dimensions. And that's what's going to end up creating those amazing projects that you're going to be carving on your machine. And I got to tell you, the first time you actually get your CNC router cutting, when you get it, it's just something that about it, like your first cut on that machine, and that machine is just doing all this really cool move that the CNC control is sending to all these different motors. So that's essentially what a CNC router is. Now, some CNC routers will have an extra capability, like the alt mill, where we can put a rotary axis on it. Now, when it comes to rotary axis, this is getting a little advanced stuff for you, so you're going to get a little more information here. Our linear axes are always termed as X, Y, and Z. But when it comes to rotary, we have A, B, and C. Rotary A means that the rotary is going to rotate around the X-axis. So X-axis is that way. That means the rotation on a rotary would be like this. So you would be looking at it like this. The B rotary means it's going to rotate around the Y-axis. In other words, the rotary would be like this, looking that way to the back of the machine. And the C, of course, is the Z. So rotary is technically the spindle rotating. So I hope that made sense, getting a little higher level, but rotaries are pretty cool, and I'm actually getting ready to get into rotary on this machine, get it set up, because so many people are asking me about it. Now that you understand the basics of CNC routers and how they work and the materials they cut, I do want to give you a quick education on the 5 types of CNC routers that are available out there. They're all designed to do the same thing, cut soft materials and move along on different axes. There are 5 levels: the industrial level, the pro level, the prosumer level, the benchtop, and the desktop CNC router. So we're going to start right at the top with the big boys, the industrial level machines. Now, these are large machines intended to do a lot of production and to be extremely flexible. Industrial CNC routers will cost anywhere from $200,000 up into the millions and are very large machines and can do a lot of production work. They're designed to work constantly, day in and day out. These would be machines for the companies that make cabinetry that they're selling all over the world, you know, your IKEA types of products. So industrial level machines, very flexible, but they're also very complex, so they require a lot of skill to run them. We're going to come down the notch to the pro level machines. Now, pro level machines are still intended for production and high speed production. The difference with these is, number one, the price point is much lower. The complexity is far lower to run, so it doesn't require as much skill, but they still have a large footprint. So generally, pro-level machines have a working area of 4 foot by 8 foot or 5 foot by 10 foot to handle full sheet goods. They just don't have a lot of the automation or multi-axes such as in industrial. So generally, your pro-level machines will run on 3 axes only. These are welded, framed bodies. They're super rock solid. They have powerful spindles on them, and they can run with generally the software that you and I will be using regardless. If you're interested in a CNC business and you're really super serious about it, you'll definitely want to consider a pro level machine. Then we're going to come down to what we call the prosumer level machine. Prosumer is kind of a hybrid between a machine that can do professional work. In other words, you can run your business with this machine, or you can do hobby work. It's at a really good price point. They don't have spindles that are quite as powerful. They can generally be set up in your shop, and they are still freestanding machines, but they are really affordable to people like you and me. For example, the alt mill CNC router, this is a 4x4 machine, and it costs about $4,500 as it stands right here. So very affordable, and this is top end in the hobby level machine. So when we say prosumer, we're also saying consumer. In other words, hobby level. If you want a good solid machine, but you just don't use it for a hobby, this is that type of machine. It's at the top level of CNC routers that you would buy for your home or your small shop. And you can start a business with it and then upgrade as you move along. The next level down is what we call the benchtop machine. So these machines generally get assembled and you have to build a table for them, and they get mounted on a benchtop. Generally, they have a smaller working area, but still a fairly decent working area, maybe 30 inches by 30 inches or a little bit bigger, sometimes a little bit smaller. They're much more affordable, maybe $3,000 at the high end. Then we get down to the bottom, the little tiny machines, the desktop CNC routers. These are the units that you can store in your closet, and when you want to carve, you bring it out and put it on your kitchen counter, do your carving, and then unplug the thing and put it back in your closet. The thing with the desktop machines is their price points are very low. You can get one for, I think, maybe $150 up to maybe $500, $600. The drawback on these is the power on these machines is notoriously low. So you're very limited in what you can cut with these desktop machines. But they're good for small spaces, and if you just want to get a feel for a CNC router, you can generally get it to play with it, and then it can be disposable. One of the things that's not so good about these machines is they're all out of China and they do not have support. So I have seen it way too often. People get these desktop machines off of Amazon, they're missing components or parts, and they have to send them back. It's a real pain, or something doesn't work and they have to contact the company, and they have a notoriously hard time trying to get the support. Matter of fact, there was one person who bought one and had nothing but problems with it. So he told Amazon was sending it back, and the company said, keep the machine. We don't want it back. It's that cheap. But if you want to just play around, there are some that will work okay. Don't expect a whole lot out of desktop machines. As far as I'm concerned, the ones that you really want to consider is either a Benchtop CNC router or your Prosumer CNC router. These are the ones that are really good for hobby work, and they're also good to start your own CNC business with. Okay, my friend, we are at the point where it's now time to start dropping you further in altitude to get you closer to CNC routers to help you understand these machines. One of the things that I want to make note of at this point is from here on out is where I'm really going to start using the terminology we use when it comes to CNC routing. I will list it down below, like at the bottom of the screen. If there's a term that I want to make sure you know, it'll pop out. And this is where you may want to get pencil and paper, start writing those terms down, just to get yourself familiar. But it's also the point at which you're going to be going, oh, that's what he was talking about in that video, or that's what they meant in that Facebook post. So this is where it gets really fun. What we're going to do in this section, I am going to talk to you about the 8 elements that have to come together to make a CNC router a CNC router. And these elements, each one is really important, as you'll understand as I explain each one, because sacrifice in any one of these elements is going to restrict the performance of the machine that you ultimately get. Here's what we're going to cover. We're going to cover the frame of the machine, the gantry, the spindle, the drive system, the motion system. Yes, those are 2 different things. Then we're going to talk about the spoil board, then the control or the brains of the machine, and finally the control software, which is your interface with the CNC. As I talk about the frames of a CNC router, I want you to think of the frame like the foundation of a house, you know, where they have to dig out all that dirt, they put up the formers, and then they pour a bunch of cement, and that cement supports the rest of the house. That's the foundation. And the same thing goes with the frame of a CNC router. It's the foundation in which the rest of the CNC router gets built on. That's how we need to think about the framework of a CNC router. Now, one quick note as we move into this, I am going to be focusing on the prosumer CNC routers and the benchtop CNC routers. I'm not going to talk about industrial machines, pro-level machines, or the desktop machines unless I specifically mention them. And the reason is because these are the machines that generally go into the home shop for hobby and for starting your CNC business. Then you upgrade later. So that's my focus. The big important thing about frames is the sturdiness. Now, this is a benchtop machine. This is the long mill CNC router. This is a 30 by 30 and it's put out by CNC Labs. This is, like I said, considered benchtop, but you see the framing that I built for it. It's a very rigid bench. I got a lot of trusses in here, and underneath I have a lot of ribs that are supporting the entire table. Most of the time when you're getting these benchtop machines, you're gonna have to build your own bench rather than put it on a workbench just because of their overall size. When it comes to the larger machines, like the prosumer machines, like the alt mill CNC router here, this is where you want to get these things with frames. This is a 4x4 in the alt mill. It also comes in a 2x4, so it's 2 foot deep and 4 foot wide. It also comes in a 4x8, so 4 wide, 8 deep, but they will come with their own framing. Now, not all machines that have this type of work surface have their own frames, which means you still have to build a table to compensate for this big working area. I like it when they come like this as a whole unit. Now, one of the things with prosumer machines, it's almost always assembly required on these machines. If the machine you are ordering is already pre-assembled, like it's just a whole unit, and it is getting shipped to you like that, then it is no longer a prosumer level machine, it is now a pro level machine. They have much bulkier bodies to them, they have more powerful spindles, and they require a shipping concern, like they're going to be shipped to you on a flatbed. Much like the machine I used to have, as you can see right here, this is a Phantom CNC router. It's a pro level machine. I had to rent a flatbed trailer, drive down to South Carolina, pick it up and drive it all the way back to Indiana. So shipping is going to be more expensive. You have to take into consideration, can you get it into your shop or not? Do you have a garage door in your shop, or do you have to pull it in through a regular door? The prosumer machines like this, they can be shipped by UPS or other shipping companies, and they come in smaller packages, and you do all the assembly work yourself. One final thing I want to talk about in this framing thing. When it comes to size of the machines, right, your frame size or the overall size is something you need to take into account when you're ordering a machine. Do you have the room in your shop to handle a machine like this, 4x4 working space, or do you need smaller space and get yourself a benchtop, which is going to have a smaller footprint? So that's one of the concerns you always want to take into account when you're ordering a machine, and frame size and just general machine size. The gantry is this whole bridge that goes across your CNC router. And it is a vital aspect of CNC routers. If you don't have a gantry, you don't have a CNC router. The whole point of a gantry is we're doing CNC routing and we're always doing it from the top. So we need something that's going to carry the spindle around the carve, and that's the function of the gantry. So the gantry actually has 4 different purposes. The first one is to carry the spindle back and forth across the bed of the machine or across the bridge. So you have this kind of travel. In the Endmills case, this is in the X direction. The second function is to carry the spindle back and forth across the front to back of the machine, or in a Y direction. So we have 2 dimensions of travel that the gantry provides. The third function of the gantry, which this is where things start to become really important, is its ability to maintain accuracy while it's making this travel. In other words, the gantry needs to be rigid enough and built in such a way with the tracks that it's riding on, the motion system, which I'll get to a little bit later, that stays consistent all the way around the travel, but particularly across the gantry itself. If it's not built so you maintain that accuracy, then you can have waviness in your project. It's the 4th function of the gantry that is the most important to me and should be the most important to you. And a lot of people don't really take this into consideration or don't know to take it into consideration. So I'm going to start it off like this. When your CNC router is cutting, it's pushing its way through the material. In other words, it's doing a lot of work. And by pushing its way through the material whilst doing the cutting, that material is resisting the cutting action. In other words, it doesn't want the tool to run through it. So you have a force of the motor that's pushing the spindle through the material. Technically, what the whole assembly wants to do as it's making its cut is the spindle wants to resist and flex like that, or flex back and forth. And the gantry needs to be rigid enough to prevent that, as well as the construction of the Z carriage, which I'll talk about when we get to the spindle. The other thing that is the absolute most important is the ability to absorb and distribute vibration that's being caused by the cutting action. So when we're making cuts, if we don't have a good solid machine that can take those forces and distribute them out into the frame, the spindle is going to bounce a little bit. And that bouncing is going to create something called chatter. In other words, you're going to have these little ridges in your cuts, and that all has to be sanded out. So a gantry needs to be constructed in such a way so that it will take that vibration and distribute it out. If the gantry isn't strong enough, what it will do is it will vibrate, and those vibrations will be sent back into the spindle, and that's how the chatter is created in your CNC project. So gantry construction is really, really important. It's one of the reasons why I like the Altmill CNC router. So this is extruded aluminum, but I know that Altmill, the guys that made the Altmill, they did a lot of finite element analysis on this to make sure that this extrusion can distribute those loads. Now I can't really show you the end of the extrusion, but the walls in the extrusion are very thick. So what that does is that takes that vibration and it distributes it down into the frame of the machine so it doesn't come back into your material to leave choppy cuts. So you can see that the gantry is a really important element of the CNC router when it comes to having good quality cuts on your projects. But you always want to take a look at the gantries. You can generally look at pictures of the machines and say, boy, that gantry just doesn't look like it has the girth and the bulk in order to be able to distribute that load or absorb flex that that's going to want to be introduced into the spindle by virtue of doing the work. Of course, the real test of the gantry when you're looking at it is if you feel like you can look at the gantry and do this when the CNC router is running. This is 170 pounds that I'm putting on this gantry, and the machine is just going to town doing this project. And I'm comfortable enough that I can stand on this thing all day long, and it's going to give me really nice cuts. So this is what I'm talking about when it comes to the rigidity and the strength of a gantry. I like that. Well, that was fun riding my alt-mill CNC router while it was making a cut. You know, that was 170 pounds sitting on top of this gantry while the machine was doing its work. Now you're getting the gist of why a gantry is so important. It's carrying that spindle all the way around that machine doing the work, and that gantry has to be solid enough to not flex and get that vibration distributed away from the cutting tool. So when you're eyeballing CNC routers, definitely get your eyes on that gantry. Just take a look at it and get a feel for it. Does it look robust enough that it can handle flexing, or it won't flex while it's making a cut? And it's built in such a way that you feel like it's going to distribute all that vibration away from the cutting tool so that you don't get chatter in your cuts. That's one of the reasons why I picked the alt mill, because it has such a strong gantry. I got a review video on the alt mill. You might want to watch that. I'll link that down below in the description. Now we're going to get on to spindles. Now, just before I start educating you about spindles on CNC routers, I want to ask if you feel like you, as a brand new green beginner, just getting introduced to CNC routers, is starting to get a little bit of clarity from this video, CNC Routers 101 type of education, then give me a thumbs up by hitting the thumbs up button down below. And I would love to know if this video is helping you and what you've learned. And the way you can do that is by leaving a comment down below. That also tells me what I'm not doing in videos and what I'm doing to help you. And if you really want to learn CNC routers, you definitely want to get into them and get your machine like the alt mill here and start learning it, then definitely subscribe to the channel, because I have a lot of videos that go step by step just like this, specifically for people like you who are brand new beginners. I walk you all the way through the design software so you understand how it works, the control software that runs your CNC router, and I walk you step by step through projects, meaning we take a project idea out of our head, I take you into the design software, and we walk all the way through the process to get that project on the router, cut it, and hold it in the hands by the time you're done with that video. All my videos are designed to give you as a beginner a lot of confidence. So definitely subscribe and thumbs up, and I really would love to see a comment. Are you getting something out of this video? And with that, my friend, we are now going to start talking about spindles. Now, without a doubt, the spindles on a CNC router is a must-have in order to make your CNC router a CNC router, because without it, it won't do any carving. A spindle does two things. Number one is it holds the CNC router bit, and number two, it spins the CNC router bit, so when the machine is moving around and has that router bit in the wood, it's actually going to carve. Now, when it comes to spindles on the Benchtop machines and these Prosumer machines, you're generally going to have one of two options. The first option is to have a trim router. That's those handheld routers that you can do when you're doing handheld woodworking to round out things. They actually adapted them to CNC routers. And the second, of course, is a true, honest-to-God spindle, the real McCoy that is computer controlled. So let's get onto the trim router first. There are several reasons why you'll find these trim routers on CNC routers. Number one is they are off the shelf. All the CNC company has to do is design around the router. They build a bracket that will hold the router, and voila, it's set up. The second thing is these are much lighter than spindles. So they don't require nearly as much robustness in the machine to support the spindle itself. Third thing is they don't have to integrate the trim router into the machine at all. Since these have plugs on them, you plug that directly into the wall and you manually turn them on and off. And then they have a speed dial right here. So you'll have to know what the speed is relative to the numbers on the dial, so you set your speed right on your CNC router bit. Now when I'm talking about speed, that's the RPM of the router. I'll talk to you about that later on when we start talking about router bits. Trim routers, they're cheap, they're off the shelf, they're easy to work with for designing into a CNC router, but the biggest limitation that these things have is the amount of noise that they make. They are so loud. The reason handheld trim routers make so much noise is because of the bearings that are in the machine. They are not as precise as what you'll find in spindles. And so when you're working it, it's just going to make more noise because the bearing is looser. Trim routers are not balanced motors. In other words, they will vibrate when you're using them. And that vibration translates down into the cut through the router bit. And the machine is just built differently from a spindle. The thing about trim routers and why they adapt them to these, like I said, they're lightweight, they're inexpensive, it saves you money at the end of the day. They're just easy to put on, but they don't last very long. Trim routers are brushed motors. So you see this little hole here, it's actually a little screw cap, and there's one on the other side. And underneath that is a carbon brush that actually makes contact with the armature or the body that spins in there. So there's a contact point in here and that brush wears out. So eventually you have to replace those brushes. Now I know some people have had their trim router last for a couple of years. I've actually been through 2 of them. This was my first machine, had the trim router, and eventually it's going to burn out. And you'll see it in Facebook or something that the spirit leaving the router, that's where the smoke, it actually burns out and the smoke comes out of it and it stinks so bad. If you don't like a lot of noise or noise is going to be a problem, you definitely want to consider getting away from a trim router or building an enclosure around your machine to keep that noise down. Trim routers work fine. But one of the other things about it is because the bearing is not as precise, you can have, the quality of your cuts can be reduced. When I went to a spindle, I never wanted to use a trim router again. It cuts so much better, it cuts a lot quieter, and spindles just work much better because they're designed for the long run times that CNC router projects sometimes require. These handheld trim routers are designed to turn on and off for a few minutes while you're doing whatever work you're doing by hand. But at the end of the day, they do work. If they didn't, they wouldn't put them on the CNC machines. Spindles are a very different type of motor from trim routers. First, they're much heavier. Second, they operate differently. In other words, they are controlled by a controller. You don't have an on-off switch on these guys. And they're designed to run for a very long time because the bearings are much more precise than what you'll find in the trim routers. These are AC induction motors, and what that means is there are no brushes that make contact in the motor. They're working on an electrical field, basically, and that means that it can go both ways. They are technically 3-phase motors. Instead of 2 prongs to make the thing run, it has 3 wires. But you don't have to wire it up like that because it has a controller that works with this. And that controller is called a VFD, or a variable frequency drive. And this is doing all the driving of the spindle based on commands that are coming from the controller. It's in the G code. There's a code that is M3 or M4 or M5. M3 turns the spindle on in a clockwise direction. If it has an M4 code, it's going to turn it in a counterclockwise direction. And the M5 code is saying turn the spindle off. And it has the spindle speed set up in that code as well. So when the controller is reading the G code, that G code is literally telling the spindle when to turn on and when to turn off. So you don't have to touch the spindle. So These are a lot more complex, as you can tell, and they cost a lot more than the trim routers, and that's why you don't always see these on the smaller benchtop machines, because it keeps the cost of the machine down. And you need to have a more rugged machine in order to hold the spindle, because it has so much more mass. You need more robust stuff just to hold the spindle in place. Now, trim routers are air-cooled. In other words, they have little fans in them, so when the armature is spinning, that fan is pulling air through the trim router. Spindles, on the other hand, can be air-cooled or water-cooled. This one is air-cooled, but they just don't make nearly as much noise when they're pulling that air through. So I want to show you the difference between a trim router and the noise it makes and the noise that a spindle makes, and you'll understand the first reason why I don't want to use trim routers anymore. When you turn a trim router on, it sounds like this. And I'm not sure if the microphone is picking up the noise as loud as it is or not, and you can also feel a little vibration out of it. It's not a lot of vibration, but there is vibration in it. And you notice also that it went right up to speed when you turn it on. Just like that. Now, a spindle, on the other hand, goes much more quiet, but I have to actually put into my computer the code to turn it on. So I'm typing in an M3, which is going to tell it to turn clockwise, and then I'm going to turn it at 15,000 RPMs. And there it goes. And you can tell it's taken some time to get up to speed. And now it's up to 15,000 RPMs, and there's no vibration out of this whatsoever. But in order to stop the spindle, I need to type in a code to stop it. So I'm going to type in the code, M5, and that spindle is going to turn off when I hit enter. And the other thing is, like I said, spindles can go backwards. Now I'm going to type in a code, M4, and you're going to see it start to spin counterclockwise. So I'll type in M4. I don't need to type in spindle speed now because it's already registered in there as the spindle speed. And I hit go, and now it's going in the opposite direction. And then I just plug in an M5 again, and that will turn it off. Now, even though spindles run quieter, when they're cutting, they actually make about the same amount of noise as you will get out of a trim router minus the sound of the motor. And that's because that noise is the actual cutting tool making us cut in the wood while it's moving around. So that aspect doesn't really change. It does a little bit because the cutting tool is not vibrating as much as it is with a trim router. Now, I do want to talk to you a little bit about a couple of terms that you're going to hear when it comes to spindles. So I'm going to loosen this one up. And we're going to take the bit out. I'm going to have to just unsnug that a little bit. That's actually a good sign. Now, first thing you're going to notice is this nut here. It's got these two little kind of drill holes. That's because this nut is balanced. You won't find this on the trim routers. And what that means is they took the nut and they spun it up to maybe 30,000 RPMs, and they have a machine that actually reads the balance of that nut, and then it'll stop it and take a little material off, and then they'll spin it up again until there's absolutely no vibration out of this, and the nut is truly balanced. If the collet nut isn't balanced, then what's going to happen is when your spindle gets up to speed like 20,000 RPM, it's going to vibrate, and it's going to vibrate significantly because this little thing is out of balance, because it's turning at such a high RPM. So you'll always want to make sure that the collet nut is balanced when you're getting your machine or your spindle or replacing your collet nuts. And not all collet nuts are balanced. So you want to make sure that if you ever replace it, it is balanced. At IDC Woodcraft, we only carry the balanced collet nuts for that reason. Because an out of balance collet nut will start to wear down the spindle a lot faster. Now inside that nut is a collet. And this is what's actually holding the CNC router bit. Now, collets on spindles are standard for your CNC router spindles that you are going to find. They have this ER style collet. ER style collets generally look like this. There are different sizes. This is an ER16 collet. There will be ER11, ER20, ER25, ER32. It all depends on the size of the spindle itself. Trim routers are going to have the collet nut and the collet as well. But the collets are going to be more custom to the trim router itself, as opposed to a standard universal collet. So you can see it's quite different. And by the way, this particular trim router was the one that was on this machine before. It burnt out. Trim routers are designated in horsepower. Spindles, on the other hand, are designated in kilowatts. So this is a 1.5 kilowatt spindle, and that is going to run off of 110 in US power, like 110 volt. But that also limits the power that the spindle can work at. So in the case of the alt mill, or just in general, the 1.5 kilowatt spindle, it doesn't have as much power as I want. So you generally want to upgrade your spindle to a 2.2 kilowatt if you're going to get a machine this size. You'll get a lot more power or torque out of the spindle, but with 2.2 kilowatt spindles, you have to have 220 single phase coming to your machine to run the spindle itself. I do recommend you get that spindle, especially if you're running a business. The stronger the spindle, the better you're going to be. So if you're going to get a machine like this, the alt mill, then definitely get the 2.2 kilowatt spindle as opposed to the 1.5. One more thing when it comes to spindles and the desktop CNC routers, the little tiny ones that you can pick up and put in your closet. The spindles on those are generally really tiny. They're a little smaller than your average 12-ounce soda can, like 500 watt spindles, which means they have very little power. And they can't hold the typical 1/4-inch shank or larger CNC bit. When I say shank, this is the part of the bit that actually goes up into the collet and gets clamped down on. This is your typical 1/4-inch shank CNC router bit. This is a 60-degree V-bit. But if you're going to a 1/8 shank 60-degree V-bit, this is what you're looking at. So you can see the difference in the shank size. This is what your desktop machines are designed to fit, not these guys. That means that you're going to have much smaller cuts. And because they don't have the power, you can't do a lot of stuff with them. Not that they're bad machines, because you can do things like Christmas ornaments and whatnot, but they are just notoriously underpowered. You're going to know that going into it. At the end of the day, we got the trim routers and spindles. Trim routers are not designed for CNC work, and even the trim router makers, they don't suggest that you use them for CNC. The CNC companies just use them because they're inexpensive, they're off the shelf, they're light, easy to integrate into the machine. The true spindle is a bit more complex. It has a controller, and it just runs better though, because it is much more precise. It's heavier. They have to design the machine around that to make sure that it can handle the weight. My friend, you've been hanging around here for quite a while now, about 40 minutes. I hope that you are starting to gain some clarity about CNC routers as you begin into your CNC router journey. At the end of the day, I want to make sure that your foundations are set. So when you finally order your CNC router, you're getting a machine that you know is reliable, it's going to perform the way you want it to perform, and it's going to turn out amazing CNC router projects when you make them. If you are starting to get some clarity in this video, like I asked you before, please give me that thumbs up and definitely give me a comment down below. I really want to know if this video is helping you out. And of course, subscribe to the channel, because this is how I go into everything to make sure you really rock it up as fast as we can get you there. Save you hours off of lots of mistakes that people make because they're just trying to wing it and figure it out themselves. Now, we are not done yet. We still have a ways to go. In this section, we're covering the 8 elements it takes to make a CNC router a CNC router. We've covered 3 of those elements so far: the frame, the gantry, and the spindle. We still have 5 to go. Now, these 5 aren't going to take as long as they did like with the spindle stuff and such, but we definitely still need to get into these so you have the right foundation when you're looking at CNC routers and you know what people are talking about when they're using the various terminology. So there's 5 things we still need to cover: is the drive system, the motion system, spoilboard control, and the control software. And then I'm going to talk to you a bit about CNC router bits, because this is another thing that's really, really important when it comes to that. And I'll talk to you a little bit about the design software. And then we're going to wrap things up, and you and I are going to part ways, and you'll be able to start looking at CNC routers in a whole different way. So at this point, let's get going and talk about the drive systems of CNC routers. After you've designed your CNC router project and set it on your router and start carving, you're committed to the job. There is no room for error. That's why we at IDC Woodcraft design and make our router bits to the highest of standards. Because your project has no second chances. We know how much time you spent creating your project and what you expect out of it when the carving is done. At IDC Woodcraft, we know that the router is doing the moving, but the bit is doing the carving. Every cut has to be perfect because that's what you expect. So that when your project is finished on the carve, it looks exactly the way you imagined it in your mind. Beautiful. It's worthy of you, your family, your friends, for sale. Make beauty from your imagination and know that your project will come out perfect. IDC Woodcraft CNC router bits, because your CNC projects absolutely must look amazing. idcwoodcraft.com. The drive system of a CNC router consists of the motors that move the machine around and the devices that tie everything together to move them around. For example, in this case, we have a ball screw on the machine that's making this go back and forth, which I'll explain in just a minute. But let's just start off with the motors. So in CNC machines, you have at least 3 motors that are moving things around. You'll have this one here that's tied to the gantry. It's moving the Z carriage back and forth along the gantry. The second one is going to be your Z carriage motor, or the motor that's moving your spindle up and down. And then there's going to be at least one motor that's going to make your gantry go back and forth in a Y direction. But generally, there are going to be 2. You'll have one on the left and one on the right. And those 2 motors will be coordinated to run together back and forth along the machine so that the gantry doesn't twist and torque. Now, the motors you're going to find on these CNC routers are called stepper motors. These are the workhorse motors, and they're inexpensive, which is why you'll find them on these machines. So the way stepper motors works are a pulse is sent to the motor itself, and that causes it to index just a little bit. And then another pulse will be sent, and it'll cause it to index a little bit more. That's really high level. I'm not going to dive into how stepper motors work. You're generally going to hear the term NEMA, which is the category of stepper motors that you're going to find. So you'll have the NEMA 17s or the NEMA 23s or the NEMA 34s. It depends on how big of a motor that the people install on their machines. These on the alt mill are NEMA 23s, but they're longer stepper motors, so that gives them a lot more torque when they're run. Now, one of the terms you're going to hear in CNC is missing steps or losing steps. And what that means is when the machine is running and then for some reason your cut doesn't work right, what happens is the machine is trying to run, but maybe the work of the CNC bit is too resistant for the power of the motor, and so the motor can't make that index, and that's called missing a step. So that's a term that you will hear in CNC. Now, there are going to be 2 types of stepper motors that you're going to find on CNC routers. The first one is what we call an open loop stepper motor. And you know an open loop stepper motor when it only has the power cord going to the motor itself. The second one is the closed loop stepper motor. And you know a closed loop stepper motor when it has the power cord going into the motor and it's got another set of wires going into the motor. And here's what the difference is between closed loop and open loop. An open loop stepper motor is receiving the signal from the control of the machine, and that's it. And so the motor is just doing what it does, but the control itself doesn't know what the motor is doing. Whereas a closed loop stepper motor is receiving the signal from the control, and it'll move and is feeding the information back to the control. So an open loop stepper motor is just receiving a signal, the control has no idea. A closed loop The stepper motor is receiving a signal and is talking back to the controller. With a closed loop stepper motor, if the motor loses steps or loses positions, it's going to communicate that to the controller, and that's going to stop the machine. In order to make this a little easier to understand, think of an open loop stepper motor like this. You're standing on one side of a wall, and someone is standing on the other side of the wall, and you can't see them, but you are the controller of the CNC, and you're giving them instructions by just tell them, move 3 steps to the left. And they just do what they do. And you assume that they've moved 3 steps to the left. And then you say, okay, now move 2 steps to the right. You wait. Okay, move 5 steps forward. But you truly don't know where they're at. And that's because you have an open loop. You're just giving the information out, but it's not coming back. Whereas the closed loop stepper motor, like what you have on the alt mill, it's going to be like this. Move 2 steps to the right. And you or the person on the other side of the wall, being the stepper motor, they're going to move 2 steps to the right. And they're going to yell back, okay, I moved 2 steps to the right. And so you as the controller says, okay, cool. Move 2 steps to the left. And then they move 2 steps to the left. They yell back, okay, I moved 2 steps to the left. You as the controller says, cool. But if you don't get that communication back, you're not going to send another signal to the motor. Instead, you're going to say, oh, something's wrong, and you're going to send an error code to the control software that's telling you that this whole thing has to stop because something's wrong. So that's the difference between open loop and closed loop. Obviously, motors are on CNC routers to make the elements move around so your CNC router will carve. But in order to get your moving elements to do what your motor is doing, there has to be something that's tied between them. And that's the other part of the drive system. So on CNC routers, there are 3 different types of drives you'll find. There will either be a belt drive, a screw drive, or rack and pinion. Now, I'm not going to cover rack and pinion here because you find those on the pro level machines and the industrial level machines. They're really meant for much more robust machines. But you will find the belt drive and the screw drive on the smaller machines like a desktop, benchtop, and your prosumer machines. So the belt drive is basically using a timing belt. And the timing belts work well in CNC. They do have a lifespan because they're constantly moving. Timing belts were used on CNC routers in the early days when the CNC routers were first hobby machines. But as the industry has developed in the hobby level, the belt drive has started to kind of lose its flavor, and it's fallen into favor for the screw drive. So there are 2 types of screw drives that you'll find. One is the lead screw, and the other one is the ball screw. The lead screw is what you'll find more on your benchtop machines or on your desktop machines, and it's this right here. It's basically an Acme thread, and it's just simply tied into some kind of nut, and when that screw turns, then the whole assembly will move back and forth. So like on my long mill here, I got a lead screw there. We have a lead screw on the both sides for the y-axis, and then there's a lead screw that's driving your Z up and down. The other type of screw is what we call a ball screw, and you're going to see that has quite a different shape to it. It actually has rounded grooves in it, and the bearing that actually runs over that is got a lot of ball bearings in it, and that's why they call it a ball screw. Now, on something like the alt mill, everything's run by a ball screw. This one here, the gantry has ball screw all the way down, and then of course the Z carriage is also a ball screw. A lead screw is very simple. It has no maintenance to it, and if you damage it, it's super easy to replace. But it is a little bit lower as far as accuracy goes or precision, whereas the ball screw is much more precise. But it does require maintenance, and if it gets damaged, it's a much more expensive replacement. So you're going to find ball screws on most of the machines that you are going to be looking at, especially if you're going to a prosumer like the alt mill. If you're going to a benchtop, then you might find a ball screw, but you'll probably find a lead screw, or you might find a timing belt. Timing belts work. They've been using them for a long time. They do wear out over time, but it takes a long time. One of the things with timing belts is they do require specific tension. And a lot of the companies don't tell you that you need to have them at a specific tension. If you don't, then you may have a little slop in it, or you may be over tensioned and you can prematurely wear that belt out. When it comes to lead screw, they work great. I like the ball screw because ball screws are accurate and they maintain their accuracy, and they have much less of something called backlash. And what backlash is basically play in between the threads and the nut. So if you put a bolt on a nut and they've been like low grade bolt and nut, and you can actually feel that nut wobble, that's got a lot of backlash to it. But if you have a highly engineered nut, when you put that screw in a nut and you put that nut on the screw, there is no play in it. That has virtually no backlash. And that's the benefit of a ball screw. They have very, very little backlash. So that's why I like a ball screw. So that's your drive system. You have your stepper motors that are open loop and closed loop. As far as the mechanical components that's moving everything around in your machine, it's either a belt drive, a screw drive, or a rack and pinion. And when it comes to screw drive, you have the lead screw and the ball screw. My favorite is the ball screw. Now we're going to cover the motion system of CNC routers, and there's generally 3 that you will find. But first you might be asking yourself, what's the difference between a drive system and a motion system? They kind of sound like the same thing. They're not. The drive system is what we just talked about, the motors and the screws that make everything move. The motion system is what keeps every element moving on a track or a straight line without wobbling, deviating, falling off, maintaining the precision as it's moving. So in CNC routers, there are 3, like I said. There is the rod and bushing, the formed wheel, and the shaped linear track. So we are going to cover the rod and bushing first. The rod and bushing in its simplest form is basically a rod that is fixed on one end and fixed on the other end, and then there's a ring that's sitting on that rod, and that ring will slide back and forth. That's called the bushing. And so when in a machine, the rod is fixed here and here, and then the moving component is somehow attached to this bushing. And so when the moving component is driving around, then it slides back and forth. And in its simplest form, the rod and bushing are almost no maintenance. If the bushing is like brass, and this would be steel, they have to be 2 different types of metal so that they don't like gall onto each other or kind of weld to each other. But a lot of times the bushing is going to be a bearing bushing, which makes it run a lot smoother. But it does have a drawback, and that drawback requires compensation. First, let me tell you what the drawback is. So we have the rod fixed to the machine, and it is fixed on each end. So just going to use that piece of wood there, and then it's fixed on this end. And the rod runs along the middle of the machine, and there's the bushing that's holding whatever moving component is there. So if there is a stress that's put on that rod, I'm going to adjust this just a little bit. So you see that if there's any stress put on that rod, it can flex. And so now we have vibration that can be introduced into the rod. So we have to compensate for that in the rod and bushing. And here's how they do it. We'll say this is the rod. So we're attached at one end, we're attached at another end, and then what they need to do is attach the rod periodically along the motion of travel. But what does that do? That creates a space where the ring can't fit over. If we're looking at the rod from the end, now these attachment points are something like this. So a round ring can't slide on it because of this attachment point. And so what they do is they split the bushing. So this bushing is going to look essentially like this. It'll go like that. And then the bushing is in a housing that's attached to the moving components. So the rod and bushing, as you can see, is a very simple system. It's just going to slide along, and all we have to do is maybe oil it up once in a while, wipe it down. There's no moving parts like bearings or wheels, so this is very clean. But sometimes these bushings will have bearings attached to them. But at the end of the day, this rod and bushing, when it's attached to these 2 ends only, and you're going over a long distance, you're losing your stability of the moving component, and it's going to start to vibrate. So that rod has to be attached, and that actually complicates things. So what do? They go to the next thing, which is the wheel. The second type of motion system is the formed wheel, and you'll see this on the smaller CNC routers, such as your Benchtops and your desktop machines. And the formed wheel is essentially wheels that are fixed to the moving parts, and they are following along a track. So the wheels are shaped And the track is shaped in the same way. So you can see on a long mill here, we have these V-shaped wheels. And those wheels ride along a V-shaped track. And the V in the wheel is matched to the track. So it can follow that track very consistently. Now the formed wheel is a very simple element because it is just a wheel rolling along a track. The wheels are always the wear items on the formed wheel track system. It's just like car tires. You drive around enough, that tire is going to eventually wear out and you're going to have to replace it. So formed wheels are good, but almost always the wheels are made of a plastic type of material. In this case, with the long mill, they are made of a Delrin. Now on the inside there's a bearing so the wheel can roll nicely. You want to definitely have a bearing in there of some sort so that the wheel doesn't bind up. Generally, you won't find the formed wheel on the Z travel. Most of the time, they're going to be linear rails, the profile rails, which I'll talk to you about next. You won't find form wheels on larger machines for two reasons. The first is that wear aspect of the form wheels. If you have them on big machines and they're carrying a lot of weight, they're going to wear a lot faster. The second reason is most of the time, the tracks are not protected from whatever debris is being introduced into the system. In this case, it would be wood. So you're going to get sawdust on the track. And think of it like this. A car riding on a very smooth track, that's going to be very little wear on the wheels. But if you're riding that or driving your car on a very rough or gravel track, that's going to cause a lot faster wear on your wheels. And the same thing happens on the CNC routers with form wheels. So because of that, that is the wear item. Whatever CNC router you get, if it has the wheels, then you definitely want to have your backups. Now, the form wheels, they work. They actually work really well, as long as you're not doing a lot of heavy production. The thing about form wheels and why they use them is because they're so simple to do. They really just require a few holes in the bracket that's moving along that track at very specific places so the wheel fits along the track just right. Maybe a little bit of an adjustment on the wheel so you can make that wheel squeeze down onto the track. Another little aspect that actually has to be maintained, because if that adjustment backs off, now you're introducing a little vibration into the machine. In the smaller machines, they work great. In the bigger machines, they won't be there. What you're going to find on the bigger machines, and my preferred aspect of motion, is what we're going to talk about now, the profile linear rail. What you're going to find most of the time on the CNC routers that you're going to be looking at and what you want is the profiled linear rail. That's what this is right here. Profiled linear rails are precision ground rails that have a very distinctive profile to them. You can see here there's a bit of a V shape in this, but it's also profiled all the way around. And what we call a linear bearing right here rides along it. So the linear bearing is a housing, here's one right here, that has ball bearings in it. So as it moves along the rail, those ball bearings roll through the bearing and they actually make a loop. And they're enclosed here. So these are very precisely ground rails, and the bearings are very precisely fit. And then there's a lot of locating holes throughout the rod to make sure that it's been positioned well and you're not going to get any flex out of these. These are made of a high-grade steel, so they are designed to last. You'll find these in industry all over the place. The important aspect about these rails is how the bearings are set up relative to the rail. So you can see on the gantry here, on the Alt-Mill CNC router, they are spread apart by about 6 inches. And that leaves for a really good gap to prevent this kind of movement. And then when we look at the bearings themselves, they are spread about 6 inches too at their maximum distance. So we have 2 of them on here on the top, and then there's going to be 2 on the bottom. So that alone is going to help the Z carriage not wiggle this way or this way. So these linear bearings are very, very precise. They do require maintenance. You will get dirt buildup inside of these over time. They do have little wipers on them. So I'm going to just zoom in here. And those little wipers do wipe away the sawdust, because sawdust is going to build up on these things, as you can see. So every once in a while, what we want to do is actually clean the rails off. And I like to drop a little 3-in-1 oil on the rail. But every once in a while, you're going to need to get inside of here. Like there'll always be like a port right on the bearing. There's one right here. And generally, in industry, you'll be able to install a grease port on there. And you can get a grease port for them and put them in, and then you can grease these up every once in a while. Or just open it up and throw some oil in there. But eventually, sawdust, the real fine powdery stuff, will eventually get into the bearing. And at some point, you'll probably have to replace it. But that's not likely to happen as long as you keep your rails wiped down every once in a while, just to keep the sawdust off of them. And of course, you have dust collection that helps prevent that sawdust buildup. In my case, since I do a lot of content, I don't use a dust collector, so I can show you what's happening with the CNC bit while it's making its cut on the project. But most of the time, you're gonna have that dust collection, and that's gonna significantly reduce the sawdust buildup that's gonna get up on these rails. As long as you're maintaining it, these bearings can last a very, very long time. This type of setup here is my preference. I want all my machines to have these linear rails on them all the way around, and they're very standard. So the good thing is if a bearing goes bad, you can go to Amazon or something like that and actually buy a new linear bearing. Generally, the rail is not going to wear down, at least not for a very, very long time. So that, my friend, are the 3 motion systems that you'll generally find on CNC routers. You have the rod and bushing, which is not going to be that common. You'll have the formed wheel, which is you're going to find on the smaller CNC routers. And then you have the linear profiled rails with bearings on them. And these are the ones that you are going to really want to orient your search on when you're looking for your CNC router. The next element that makes a CNC router is the spoil board. That's the working surface that you're going to take your project material and place it on and clamp it down, and then the CNC router is going to come around and cut the project out. Now, the spoil board is also known as the waste board, and it is intended to be a sacrificial component of your CNC router. So spoil boards are made of a material in general called MDF. That's micro density fiberboard. That material is basically a very soft material that's been glued together, and if a router bit cuts into it, it's not going to hurt the router bit. So you can do project cutouts, and if that bit cuts into the spoil board, it doesn't really matter. Now we call them spoil board or waste board because they are sacrificial, because over time we end up running our CNC router bit into the spoil board, and after a while it can be pretty much ruined, and then we have to replace the spoil board. If you look closely at mine, you'll see I've cut in right here. I've got some light cuts in it right there, and there's another cut going around the spoil board right there. And generally, over time, you'll have done that so much that the spoil board really doesn't have a lot of good surface to work with anymore, and then it is spoiled or wasted. Hence the name spoil board or waste board. And what you do is just replace the spoil board or the components of the spoil board. Now, the spoil board has a much more important purpose than just being this soft material that a router bit can cut into that doesn't ruin a router bit. It is the surface in which you place your projects down on. And the importance of that surface is it has to be parallel to the motion of your CNC router across the entire project. The spoil board may have a waviness to it, which is generally the case when you first install your spoil board. And if that waviness is there, then your project material is not sitting parallel to the motion of the machine. In other words, it may be like this. And that could mess up your carbs, especially if you're doing fine detail carbs like V carbs. And so what you need to do is surface the spoil board. And this is the very first thing you do when you get your CNC router put together. So you see in this video, I am running a surfacing bit across the spoil board. That is flattening the spoil board so that from here on out, the spoil board will be flat when I set my project material down on it. Over time, the spoil board may lose its flatness, and so every once in a while we'll need to resurface it. The thing about MDF material is because it is this kind of paper type of material, It does react to humidity. So if you live in an area where the humidity goes up and down, up and down, up and down, that spoil board is going to swell and contract, swell and contract. So I've seen people make their spoil boards out of something called HDPE, or high density polyethylene, or something to that effect. It's a type of plastic, and that does not get affected by the humidity difference. But that's costing you a lot more than the spoil board material. One of the things you're going to see with my machine is we have all these tracks on the machine here. So these are called T-tracks, and they are very common on CNC routers. What that does, it gives you the ability to place your clamps around your CNC projects wherever you want to. You can see right here, I have these clamps, these little tiny clamps that I'm using in the T-tracks. These are actually called edge huggers, and they're very small, high pressure or high holding clamps, up to 1,000 pounds per square inch. And it applies all the force right on the board, and they're very low profile, so you don't have to worry about the CNC router colliding with the clamp, which is something that happens. And you can see how these T-tracks are placed in the machine. Now, T-tracks are not a standard item when you order your alt mill or whatever CNC router you're going to get. These are something you'll have to order extra. There are other ways to set up your CNC router spoil board, as you see in these pictures here. You see people have done holes in their spoil board for cam clamps or something to that effect, and not using T-tracks. Personally, I like the T-track idea because it is so flexible, gives me a lot of options to do lots of different things. But if you are getting into production with your CNC machine, like starting a business, then you may not want to use T-tracks. You'll do other things like create fixtures. Personally, I think that T-tracks are the best way to go. So when you order your CNC router, make sure you order T-tracks with your CNC router, either from the company you get your machine from, or you can get them at IDC Woodcraft, or some other source where you can get T-tracks from. At the end of the day, the spoil board is very necessary to make sure, number one, that you have a nice flat surface that your project can sit on relative to the motion of the CNC router, and that it is sacrificial, that you can cut into it by accident and not worry about damaging your router bit, and can replace the spoil board later on. My friend, at this point, you and I have covered 6 of the 8 elements that makes a CNC router a CNC router. The frame, gantry, spindle, drive system, motion system, and the spoil board. These are all the physical components of a CNC router. And without the final 2 elements that we're going to be covering now, this is nothing but a very well designed and very expensive paperweight. We need these final 2 elements to turn this into an imagination creation machine. So we're going to talk about the control and the control software. And I'm going to start this part off by taking you back to the whiteboard to explain these 2 to you and how they stack together that makes this machine do what you want it to do. Let's get over to the whiteboard. The control software and the control are the 2 things that have to come together to make your CNC do exactly what you want it to do. But this can be a little confusing when I'm saying control software and then control. So I'm going to get a little more specific and use the proper terminology here. We have the control software, that's the proper terminology, and then we have the CNC controller, or also known as the motion controller. So the control software is your interface with the CNC router, where you tell the CNC router what to do, and you can visually see what it is doing or what it has done. So the control software is your interface for your machine and your command center for it. So in my case, this is my user interface, my control software that I can interact with my CNC router and command it to do what I want it to do, whether I want it to carve a project or move around or set the 0 for all the points that, for the origin point of the CNC project. So this is called G-Center, and it's what comes with the alt mill CNC router. So we're going to take a closer look at this, and you can see the big black area here has some numbers in it. These are the toolpaths. This is what the CNC router bit is actually going to be doing, and it's showing me how the router bit is going to move around the machine. And then over on the side, these blue buttons, this is how I can jog the machine around to come to a position that I want it to go to. So if I press the X plus button, the machine moves to the right. If I press the X minus button, it moves to the left. Y minus, the machine will come towards me. Y plus, it'll go away. And then of course Z minus, the spindle goes down, Z plus, it goes up. There are some other buttons up here. These buttons here is how I set the 0 point for, or the origin point of my carve. For example, you're looking at this picture right here. This point where this green line intersects is the origin point of this CNC project. This is a part of a cribbage board. So the origin point is to the back left corner of the material. This doesn't show the material, but I know it because I can go to the design and see it. And this also enables me to load the program and to start the project. So if I was to hit the start button, then the machine would start running. So that is my interface. So you can see that I can do anything I want with the CNC. I know exactly what it's doing from this interface. So now that you know about the control software, we need to talk about the CNC controller. The CNC controller is the circuit board or circuit boards that's actually telling the motors what to do and when to do them. With the Endmills CNC router, the controller is mounted on the side of the machine. Now I've taken the cover off, but you can see it is a circuit board. And we have lots of wires going into it. Here's the 4 motors that are plugged into the controller. Here are the wires for the closed loop section. Here's some sensors. There's lots of other wires that are going into the controller. Now the control software is feeding information to the controller, and the controller is telling the CNC router what to do. So when I pressed the jog buttons in the control software, that sent a signal to the controller, and the controller then activated the motors. So the CNC controller is running the CNC machine based on information that is coming from the control software. So here's how this works. We'll just say we're going to move the machine in the X direction, in the positive X direction. That would be to the right. When we push that button, the control software is going to send a signal to the CNC controller. And the controller is going to take that information and feed it to the CNC machine to the proper motor that it needs to feed it to. And then once it does that, it's going to feed that information back essentially to this control software and say, okay, I've moved here. And you'll have a visual to see where the CNC machine is at least most of the time. So that's one of the uses for the control software. The next one is when you're zeroing out tools. You'll move the CNC bit to the proper location that you want your starting point to be at, and then you tell the software, this is where I want to zero it out at. And so what's going to happen is you're going to press the X0, Y0, Z0 buttons, and the control software is going to send that signal to the CNC controller, and the controller is going to say, okay, now this is my start position where I'm going to do all my work from. And then finally, there is actually running your CNC project. Now the CNC project is something you design, and then you have to set up toolpath, and then you're going to create a file that's going to be sent to the control software. And that file is called a G-code file. Now the G-code file contains all the instructions that your CNC router needs to do what you want it to do to carve out the amazing project you're going to have it carve. But you have to take that G-code file and plug it in to the control software. Once it's in the control software and you have your zero position set for your X, Y, and Z tools, then you hit the start button. Now what's going to happen is the control software is going to automatically start sending signals to the CNC controller. And the controller is going to start sending signals to the machine, motors, spindles, and whatever other devices. And then it's going to send that information back to the control software so you can see what's going on. And the control software is going to send more code to the CNC controller, and that's going to run the machine. And it's going to keep doing that until the G-code file is completely run out, which when that happens, your project will be completely carved out. The important aspect of this is to understand the difference between the two. The control software is your interface with the machine, generally on a computer. The CNC controller is the brains of the machine that is actually telling the motor what to do. Well, my friend, we've been at this for about 1 hour and 20 minutes now. Hats off to you for hanging around. But we're not done yet. There are still some important aspects about CNC routers that we have to cover. I got to educate you about design software and about doing toolpaths and about G-code, the instructions that make your CNC router do what it's going to do. And I've got to educate you a bit on CNC router bits. So that's why this video is going to go on for about another 40 minutes. But I got to tell you, you're getting a thorough education into your introduction into CNC routers. Now, I just want to let you know, you hang around a little longer because I've got a special bonus for you if you do. And you're going to like that bonus. So what we're going to get into now is the design software and continue on. Hey, if this is helping you out, give me that thumbs up and a comment down below. Subscribe to the channel. Let's get into design software now. And remember, I got a special gift for you, a special bonus, a little later in this video. So hang around. In order to create any CNC design, you have to design it up. So the design software is your very front end of creating CNC project. The design software is where you take the idea out of your head and start to shape it up into something that you like, and then you can tweak it and twist it around. You may not even know exactly what you want to create, but as you start to fiddle with the design software, it just tends to form up. You can see here I'm making a project for my friend Patricia, who's getting married shortly, and I'm just working this up. I don't know what it's going to look like, but this is where I feel this out. The design for this project is now done, so we now need to get into the next section of this, which is creating the toolpaths to tell your CNC router what CNC router bits are going to do what and with what bits. But before I get there, this whole design thing, this is where most people get intimidated with CNC routers and what tends to stop most people from actually getting into this amazing world of CNC routers. And it's the design, the software, it's designing because they've never done design work on a computer. A lot of people that have gotten into this didn't even know about computers or how to work them. You're not alone. We have all started at zero, including me, and it's very intimidating in the beginning. But I tell you what, once you start to get it and understand it, it's so rewarding. And besides, that's what this channel is all about, to help you as a brand new CNC creator start from zero and get going up into an amazing creator with your CNC router. So if you're feeling intimidated, it's okay. That's where we all start at. I promise you, you will get this. All right, now let's talk a little bit about tool pathing. So there's this aspect in CNC. First we have CAD, C-A-D, and that stands for computer-aided design. That's the design aspect. Then we have CAM, C-A-M, that stands for computer-aided manufacturing. That's where we set up the tool paths, where we are telling the CNC what bits we're going to use, and when, where, and the steps or in the order in which they're going to be used. So you can see here with the Patricia project, I am now starting to set up the toolpath aspect of it. The thing with setting up the toolpaths is this is where you can render the toolpath strategy to see what the project is going to look like in the end. And if you see any mistakes or something that doesn't look right, this is where you can make corrections in your design or in which router bit you're going to be using to do what. But this is where it all comes together. And as you can see, I have now created this wedding sign for my friend Patricia. And I have worked up all the toolpath strategies. It looks awesome. Now we're going to take that toolpath information and we are going to turn it into G-code, which is the set of instructions that we will plug into our control software that's going to tell the CNC router what to do. So G-code is the next step, and it's a fairly easy step to do. We don't really need to know G-code, we just need to know that G-code is a necessary part of the process. So I want to talk to you or show you a little bit about what G-code is and what it looks like. So we're back in the Vectric Design software and we're in the toolpath setup area, but now what I'm going to do is direct it which toolpaths I want it to use to write the code, and I'm going to go and tell it to save that code. And what it's going to do is going to write the file. So I'll just make sure it's going to the destination I want. I'm going to give it a name, Patricia, and then I'm just going to tell it to write the code. And then when we open up the directory, there are our 4 G-code files that we've created from this program that's going to create the Patricia sign. So we're going to go open one up, and let's see, let's open up this last one because that's going to be the simplest one. I'm going to open up a notepad. So G-code is a text file, so you can edit it very easily if you need to. But G-code, in its essence, has the letter G in front of many of the lines, but each code stands for something. Like this G20 tells it to go in inches, and the G90 is saying we're going to use absolute coordinates, and stuff like that. You don't really have to know this, but I just want you to understand what a G-code file does. So it sets up the parameters of how the machine is going to read the file. And then it's going to have different things. Like here is that, remember I told you about the M3 code? This is where the spindle is going to turn on. And this is the RPMs that it's going to turn at. Now there are X, Y, and Z movements right there. And this G0 is telling it it's going to move in a rapid motion. And then if we come down here, it says G1. That's going to tell it we're going to move at a feed rate that's defined by the database of the router bit that is being plugged into this certain thing. So it's going to be running at a feed of 30 inches per minute for this particular motion. But you'll see G code and M code. So the G code has to do with motions of the router for while it's just moving around doing its stuff. The M code is something that the machine is going to do. In other words, this M3 will turn the spindle on. So that's a machine function. There may be an M5 that's going to turn the spindle off. There's an M30 at the end of the code, or an M2. Let's see what's here. M2, this is telling us that that's the end of the program. So G-code is essentially the written instructions written by the design software that is sent over to your control software. And your control software is going to read it, and it's going to send it to the router, and it's going to tell it how to move around. Now, the thing to remember is the G-code is basically the order of movement. So it's a incremental step-by-step of how the CNC router will move around throughout the carving process. At this point, we have covered all the aspects of CNC routers that makes a CNC router and the elements that make it go. So we've got the motion system, drive system, spindle, spoilboard, frame, gantry, the brains of the machine, control software. We talked about design software, the toolpath aspect, and also G-code. What I've not done is put this all in a logical order for you so you understand the entire flow of getting an idea and making it all go through the process and hold it in your hand. What's the logical flow of CNC routers? So I'm going to do that next. After that, I'm going to talk about CNC router bits at a high level, because after all, a CNC router is not a CNC router if you don't have the cutting tools to go with it. So I do want to give you a high level education on CNC router bits. And that's why there's another 30-ish minutes in this video. As far as CNC machines go, I've been demonstrating the alt mill CNC router here. And if you're interested in getting the alt mill, then I linked that down below. Also a deep dive video I did on the alt mill, so you really get a good feel of whether this is a good machine or not. Remember, I stood on this machine when it was carving. That's why I like this machine. So if you're still in the market, you might want to consider the alt mill. One more thing is you've been here for a long time and you're brand new. One of the things you're going to have to do when you get your CNC is get CNC router bits. And because you're so dedicated to watching this video, I'm going to give you a bonus. And that special bonus is a one-time introductory discount to your CNC router bits at idcwoodcraft.com. So what you'll do is you'll go to idcwoodcraft.com, populate your cart with your first set of CNC router bits, and at checkout, you will plug this code in, and this will give you an automatic 10% discount across the board on all the IDC Woodcraft branded products. Use this code at idcwoodcraft.com, get your special introductory one-time discount, and you'll be off and running to get into your CNC routing. This is for you hanging around this long. It's because I know you're serious about this stuff and I want to help you get on board. And I will link the 3 sets that we have down below, because you really would just want to get with a starter set. So I'll link those down below. Just remember that discount code, that's right here. Use that when you check out. Okay, let's talk about the logical flow, and then I'm going to get into CNC router bits. Let's tie all this together in the logical order of how you take an idea and put it through the entire process of a CNC router and get that project in your hand. First, of course, is your idea, whatever you want to design up. And that you're going to work with the CAD part of the software, computer-aided design. So this is where you're going to be doing your design work. And design is always two-dimensional. You're just drawing lines on a flat surface. So that's what I mean by two-dimensional. Once you're done with that, then you're going to CAM. computer-aided manufacturing. In this case, you are setting up the tool paths. You are telling the software what CNC bits you're going to be using on what parts of the design that you have. Once you've got the tool paths done, you are going to render that or turn it into an image that you can see of what it would look like after it's carved on the computer. And you'll be able to look at that and say, okay, everything looks good. If it all looks good, then you're going to generate your G-code files. And those are the sets of instructions that are going to be sent to the CNC router to tell it how to move around and turn on the spindle and all that good stuff. So the G-code file is now going to be plugged into your control software. Okay, and that is, in my case, G-Sender. There's different control software out there, but the control software is your interface with the computer, with the CNC router. Now what you're going to do is do your machine or your project setup. Project setup is very important. And what that is that you're putting your project material on the CNC router, you're clamping it down, you are putting your CNC bit in and all that good stuff. Then you're going to zero the machine. Okay, and zeroing, basically you have to make sure you're telling the machine the start point of the project. So now we have zeroed the machine with the CNC bit in it. The project is set up. Now you hit start. And what is going to happen from this point is the control software, we're going to move that down here. So now it's going to go automatic. The control software, we're going to write it again. Control software is now going to send signals to the CNC control. That's the circuit board that's running the machine. And the control is going to start reading the signals. Those signals are the G-code. The lines of the G-code. It's going to send the first line, then the second line, then the third line. And the CNC controller is going to be saying, okay, I received that code, and it's going to tell it I'm ready for the next one, but it's all going to kind of keep it all in order, right? The controller is going to keep it in order. It's going to bring the code in, and the controller is going to manage all that code. And it's going to start feeding the information to the various elements of the machine. It's going to turn the spindle on. And it's going to move the axes, so motion. And it's going to keep doing that until it runs through the entire G-code program. Once we hit the bottom of the G-code program, then what's going to happen is the spindle is going to turn off because the G-code says turn off the spindle, and the machine is probably going to go back to your reference 0 point. So it's going to work all the way through the G-code file until it hits the end. You now know how CNC routers work. Now we're going to talk about CNC router bits because it doesn't do anything without bits.
Again.
What happened?
I broke another CNC router bit.
I told you, stop getting those cheap router bits. You need some quality CNC router bits.
Did somebody say quality CNC router bits?
IDC Man.
Who is this?
It's IDC Man, the CNC superhero.
Oh, you mean like from idcwoodcraft.com with the premium CNC router bits.
That's the one.
I heard a CNC router bit snap.
That was me.
What happened?
I keep buying the cheapest thing on the internet, hoping it'll work out.
I hear this all the time from brand new CNC router owners. They invest in their CNC routers, their shops, and all the time to learn it, but they keep buying cheap CNC router bits.
Guilty.
What are you gonna do from now on?
Get the quality bits from idcwoodcraft.com.
I am so glad to hear that. Oh, what's that? I heard another CNC router bit snap. I have to go save another brand new CNC router owner who is buying cheap CNC router bits.
Better go.
Remember, where bad quality fails, IDC Woodcraft prevails.
IDC Man. I better get this bit replaced from idcwoodcraft.com. There it is. Thanks, IDC Man. And I can already feel the quality difference. I'm ready to get started.
This section of the video is probably the most important for you because we are going to be talking about CNC router bits. Why is this so important? Well, basically, as you know, this is where the rubber meets the road. Think of it like this. A CNC router is a machine that's designed to move around in space and spin a cutting tool. But it is that cutting tool that actually contacts your material, removes material, and ultimately turns it into a project that you can hold in your hands and be very proud of. And this is the element that does it. So it's basically the 9th element of a CNC router that makes it a CNC router. So here's what I'm going to cover in this video. We are going to first tell you what not to use on a CNC router as far as a cutting tool. Bit materials, construction, some of the terminology that you're going to be hearing. Then I'm going to introduce you to the 9 common types of CNC router bits out there, and then we'll do a wrap up. What I'm not going to do is go deep into this because I've got a full-blown video that introduces you to CNC router bits, and it covers things at a much deeper level, which I absolutely recommend that you watch. I will link that video down below. It also tells you what bits you need to start with and how you want to progress through your CNC router bits as you progress into CNC routing experience that you are going to have after you get your machine. So let's start off with what bits are not to be used in a CNC router. The type of bit that you never want to use on a CNC router is a bit that has a guide bearing on it, just like you see here. A guide bearing is designed for handheld routers and is intended to keep the tool at a certain distance from the edge of the material so that the cutting tool cuts properly. Why can't you use it on a CNC router? Well, CNC routers sometimes make sharp turns or have tight angles in there, and the guide bearing itself may not fit into that corner. And this guitar-shaped trivet is an excellent example of why you don't want to use a guide bearing. There's a couple of points here. Number one is this corner here. If you have a guide bearing that tries to get in there, it cannot fit. The other is there's a little space right there. It can't get through it. So if you try to use a guide bearing on your CNC in a case like this, the machine is going to try to push it and it's going to stress everything. It may move your project, it may break the bit, it could throw your machine out of tram. And tram is not something I've talked to you about before. I'll introduce that to you here in just a second because it's a very important term that you need to know about. So guide bearing bits, never, ever, ever use them on a CNC router. The CNC router is the guide. The computer tells it what to do. So there's no tactile sensation with the CNC bit if something goes wrong. So if it does get into a corner and it jams up, the machine doesn't know it unless you have a closed loop machine, right? Then it's going to say, hey, something's wrong here and stop. But you already caused yourself some problems. So never, ever, ever, ever use a bit with a guide bearing on it. Now, just before I used the term tram and said, oh, this is something that you absolutely have to know about. And you do have to know about it, and you will have to know about it, and it's something you're going to deal with when you get your CNC router and get it set up. And it's one of the first things you'll have to do after your machine is completely assembled and running. So what tram is a reference to the spindle itself and the angle at which it's sitting relative to the working surface, so the spoil board. So when you set your CNC router up, your machine is going to be out of tram. In other words, the spindle is going to be skewed like this, one way or the other, not only side to side, but back and forth. So this is what we call in tram, yaw, which is side to side, and nod, like that, which is back and forth. And we have to adjust both of those so that the spindle center is perpendicular or 90 degrees to the working surface, both in the X direction and in the Y direction. Because if you do not make sure that's set up properly, when your CNC router bit starts to cut through the project, and we'll use the surfacing bit as our reference, it will technically sit like that. Now that's very exaggerated, but it'll sit like that at an angle. And when it starts making its cuts, you can see that it's actually going to create steps in the project, and that makes your project look bad. So when the spindle is out of tram, that's the term, out of tram, it has to be adjusted so we can get it in tram. So in tram is the spindle is at 90 degrees. And the way we have to do that is by using, there are several devices you can use to tram your machine, but one of them is a tramming bar. And basically what a tramming bar is a long bar that gets clamped up in your spindle, and it has this other pin here that you bring it down close to the surface of your spoil board, and then you spin it around. And if your machine is out of tram, we'll exaggerate that, we'll put it like that, and we'll say your spindle is sitting like that. When you spin this around, the other side is going to have a much bigger gap on the spoil board between the bottom of this pin and the spoil board. I figure this is a good opportunity for me to check my machine to see if it's in tram at the moment. So I have put the tramming bar in my spindle. I brought it down very close to the spoil board, but it's not touching the spoil board. And then I can swing it around. And so far it's good, but when I come over there, now it just hung up on that side. Now we go to front to back, it's actually pretty good. So what that's telling me is my machine right now is out of tram, and the spindle is actually sitting like that, just ever so slightly. And that's how you're gonna see that the machine is out of tram. So what you have to do is adjust the tram of your spindle so that when you swing it around, that gap between the spoil board and the bottom pin is the same on both sides. So this basically just magnifies the deviation of the machine of how it's out of tram. So you'll have to adjust it first side to side and back and forth. This is something you were just going to have to deal with when you get your machine, because it's like this on all machines. Tramming is a pain in the butt. It takes time, it requires patience, but once it's set, your machine is going to cut very, very well. When it comes to tramming the machine, the yaw, or side to side this way, in the X is actually easy. You'll loosen up a couple bolts, you'll just move it a little bit, and you're set up. But the back and forth is much more difficult because of the assembly of the machine, and this is across the board. The guys that made the alt mill said, how can we make this a lot easier? And they actually came up with a technique in the machine design so you can adjust the nod, the back and forth, much easier. When it comes to tramming, that is it's a huge, huge perk that someone built into their machine. That's one of the reasons why I like the alt mill. Now you understand that what tramming is and why it's so important, and that you will have to deal with it, because your spindle will not be in tram when you set your machine up. All right, now that you know about that and how important it is, don't forget about that. I will link videos down below that talk about tram, and let's get back on to CNC router bit. Now we're going to cover the materials that CNC router bits are made of, how they're constructed, and some things you want to be aware of, and we're going to talk a little terminology here. So first of all, the materials, or how they're made. The first one is the solid carbide tool. So this is a 1/4 inch downcut end mill, and the entire tool is made of solid tungsten carbide steel. It's an alloy steel. Tungsten carbide is used widely in machining because of its high heat resistance, its high strength, its tendency to hold a sharp edge for a long time. Carbide is fairly expensive, but it stands up to a lot of work on machines like CNC routers. The next one is the brazed tip CNC bit. The brazed tip is a CNC bit that's made of 2 component materials. You got the body here, which is generally made of 4140 or some kind of steel, and then the carbide tips are welded or brazed to the cutter, just like this 150-degree V-bit. It's been brazed to the cutter as well. And the reason they do that, number one, is because carbide is so expensive. So if you've got a 1-inch tool, carbide solid blank, and you're grinding it down to all this, there's so much work involved in that, and there's so much carbide that this tool would probably cost like $350 or more. The brazed tip bits are generally used when you have a wider body than the shank of the bit. And then the third one is the replaceable insert tool. So this is another surfacing bit, and these are the cutting tool edges right here. Let me get a better focus on that. These are the cutting blades right here, but you can see there's a screw there, so they are replaceable. So if it breaks or wears down, then all you have to do is replace the tip. The one thing you want to stay away from is any bit that declares itself high-speed steel. If you're going to Amazon, you're looking for CNC bits, and they have an HSS next to it, then that is not the material you want to use. So high-speed steel is very different from tungsten carbide. It's what your standard drill bits are made of. And high-speed steel does not have the tolerance of these bits, and it's much more flexible. So I'm going to show you. We got a thin drill bit right here. It's made of high-speed steel, and that is flexible. I can literally bend that bit. So what the problem is that's going to be introduced here is, number one, it does not have nearly the heat tolerance of these bits. It's not going to stand up to the high speeds of CNC routers, and it's going to flex. You're going to get what we call bit deflection. So there is a little bit of bend in the carbide bits, but very, very little. You try to bend that, you're not going to get it. But the drill bits, you can actually get a bend out of it, and that is going to create a lot of deflection, cause a lot of problems in your cuts. So you never, ever want to have a CNC bit made of high-speed steel. The CNC bit, the common terms you're going to hear are the shank and flutes, or number of flutes, and cutting length. So the shank is the blank part of the bit above all the cutting edges. This is what goes into the CNC router, into the collet, and gets held in the CNC router. So this is the shank, that's the shank, that's the shank, and of course, that's the shank. Now, the next term is the flutes. We generally refer to the flutes as the number of cutting blades that are going to be on the CNC bit. The flute is actually the channel that's cut in front of the cutting blade. The blade itself is actually called the cutting tooth, but that's what people do. So let's say, how many flutes is on a bit? Or it's a 2-flute bit. You can look at this one on the end, and you'll see that it's got 2 cutting blades, or 2 flutes. So this is a 2-flute bit. And then the cutting depth, right? The cutting depth is the length at which it can cut. So the cutting edge comes up to about right here, and it goes all the way down. So that's a 1-inch cutting length. Again, we have the cutting blade here. The cutting depth is technically along to the top of the angle, unless you want to use that step. And this bit has 2 flutes. This is a 4-flute end mill, or surfacing bit. It's 1, 2, 3, 4. And it has a cutting depth of 1/4 inch, which you measure right there. And then, of course, we got this bit here. It's also a 2-flute bit. One other term you're going to hear a lot when it comes to CNC router bits is the term chip load. In its purest sense, chip load is how thick of a chip or cut each tooth on the CNC router bit can take off the material during each rotation. Chip load is a very effective thing to know about, but I'm not going to dive deep into it here. I've got a video that goes into the chip load as well, so you get a much better understanding of it and why it is such an important term. That video will be linked down below in the description of this video. Now we're going to cover the 9 CNC router bits that you're going to need to know about eventually. And we're going to start from the most important down to the least important or least used. Here are the 9 CNC bits that we're going to cover. The surfacing bit, straight cutters, V-bit, the ball nose, the taper ball nose, that's one you're really going to like. Then we get the bowl and tray bit, the roundover bit, drill, and the engraving bit or the drag bit. The surfacing bit is your most important CNC bit you'll ever have, and it's the first one you will use because of what it does. So the surfacing bit purposes are, number one, is to flatten your spoil board. Remember when I was talking about the spoil board as a component of your CNC and how important it is to have flat and parallel to the motion of your CNC router. So the surfacing bit is the tool that is going to do the flattening of your spoil board. So that's use number one. Number two is your raw projects. This is raw milled lumber, so I will surface this off before I start to run it as a project. And most lumber you will need to surface when you set it up in your project. Even though it might measure right, you might have a warp in it or something. You need to surface that warp out of it. And number three is, let's just pretend this is a botched project, which essentially it is. I just did this cutout for example. So what I need to do is remove all this material. So I'm going to just use the surfacing bit to remove all the material. And that way I can save this piece of oak to come up with another CNC project. So those are 3 main uses of a surfacing bit. The rest of those uses are explained in the video, that deep dive video about CNC router bits. The next category of bits are your straight cutters. To be clear on what a straight cutter is, it's essentially when the tool passes through the material, the bottom of the cut or the profile of the cut is going to look like a box. So it's going to be cornered off. So let's just pretend this is a piece of material here and the cutter is going to go into the wall, into the material just like that. The profile of the cut is going to be a box, squared off. We're going to have sharp corners right down there. So essentially the straight cutter is going to look just like this. And the cutting edges are going to be on it just like that. And then the upper part is going to be the shank. Or it can be reduced. So there's the shank and then it tapers down to a smaller diameter. We'll say this is a 1/4 inch shank and then it tapers down to a 1/16 diameter, but the bottom of it is still straight. It's still a boxed off cut. Now there's different configurations of straight cutters and there are straight cutters designed for different materials. So let's talk about the differences between them. And we're going to talk about first the ones that we use in wood, and you're going to learn some terminology here too, something you're going to be hearing a lot of. So these are 1/4 inch cutters, and they are all different, even though they may look the same right here, but you're going to know the difference now. So this first one is a down cutter, and we know that when we rotate that, the spiral goes down. So it's making a cut, but the cut is going downward. And the intent behind that is when it makes its cut around the project, it's going to leave a nice clean edge on it. And it will not have what we call tear out. There's another term for you, tear out or chip out. You can see we have a lot of tear out right here. A down cutter will not give you that tear out. It'll leave a nice clean top corner. The next one is the upcut end mill. So when we turn that one, the spiral is going upward. So this one is going to leave the tear out here, but it's better for material removal. The difference between the down cutter and the up cutter is the up cutter has a cutting edge on the bottom, whereas the down cutter does not. The third one you're going to hear about is the compression cutter, compression end mill. So when you spin this one, you can see the cutting blades are going down, but if we take a very close look at this, I'm going to just set it in position here. We're going to zoom in on it. You're going to see that right here, there's a little bit of an upcut to it. So when I turn it, you can see the down cutter part going down, but at the very bottom right here, there's a bit of an upcut. And so what it's doing, it's cutting downward with the chips, and at the bottom it's cutting upward, and that compresses the chips into this area right there. The benefit with this is it eliminates the tear out at the top of the project, but with that bottom cutter, because this has a bottom cutter on it, just like the up cutter, then it'll leave a smoother cut on the bottom, whereas the down cutter doesn't leave quite as smooth of a cut. So these, like I said, can be in different diameters. So there's a 1/4 inch shank, and this steps down to a 1/16 inch diameter. But you can see they step down, but the cutter is squared off. So there's another one for wood that is also a straight cutter. And when we get a close look at it, you see it's got these knurls on it. This is called a roughing end mill. And these are designed to remove material very quickly and aggressively. As you can see in this video right here, it's taking material out very, very quickly. So that is what these straight cutters are used for, the different terms. And these are all for wood. Now, you're going to hear an O-Flute cutter or a single flute cutter. It's commonly called an O-Flute cutter. And that's this guy right here. So when you spin it around, it only has one flute on it, one cutting edge. And this is designed for your acrylics or your plastics. If you look at the bottom here, it doesn't look straight. It's kind of tapered down like that. But the end result is it's going to leave a cornered cut. Straight cutters will be the most common bit that you use for most of your projects. The next most common will be your V-style bit or your V-grooving bit. So it's very obvious what you can see here. It's got a V shape to it. If you put it that way, now it's got a V shape to it. This is a 120-degree V bit, and this is a 150-degree V bit. You'll find them in 90 degrees, just like that, or 60 degrees, like that. Here's your a very high detailed 30-degree V-bit. V-bits are good for chamfering, but the best part of them is for the detail work. So on the scrimmage board, you can see these grooves, those grid lines. That's all done with a V-bit. And then you got the lettering, like the word finish there, as you see it's carving out in this little image. So V-bits are good for that kind of detail. It's good for what we call V-carving. So you see this word, hello CNC, and we get a close look in there. That's actually cut by a V-bit. And the nice thing about V-bits is they can create nice sharp corners in your lettering and your other designs. This is something that somebody made for me, and they did it all with a V-bit there. You see here, we did some really fine detail lettering on this game board that I made for my niece. Live, laugh, love, and play games. That's done with a 60-degree V-bit. And the other thing that's really good is like when you have script that changes in thickness as far as the lines, the V-bit is, and the V grooving method or V carving is designed to pick that up. So you can see this swirl here. It has a thick area on the lines and then it goes really thin. Well, that V-bit is moving along and is picking up as it's going along, so it's maintaining the vectors as far as their thickness. So you can get really cool detail like this and it looks really nice. And same thing with lettering. So here in the J, it's a little thin right there, it's thick there. That's what V-bits will pick up for you. And there is that project, by the way. As I finished it, you can see I changed the detail on it and did a little design work on it. So this is that one we worked on before when I was showing you the design work. So much fun to make. Not only are V-bits excellent for this type of detail, script and fine detail lines and whatnot, they're also excellent for carving stars. If you want to carve American flags and carve the stars in the Union, V-bits do a perfect job at creating the stars in the Union. Another very common bit is the ball nose, B-A-L-L nose, not to be confused with a bull nose, B-U-L-L. A bull nose looks like this, where the edges of the corners of the bit are rounded over, but it's flat on the bottom. So it has a slight radius at the edge of the bit. A ball nose is literally a ball shape at the end. It's completely rounded, and you can see it come in lots of different sizes. So we have 1 inch, 3/4 inch, 1/2 inch. There is 1/4 inch, 1/8 inch. So ball nose are good for a lot of different things. They're good for adding accents to your projects. In cases like these larger ones, they're great for the juice grooves and cutting the juice pockets in cutting boards. Then things about the smaller ones is you can do 3D carving with these. So the 1/4 inch is really good for doing a large 3D carving and still maintaining your detail. And the 1/8 is actually really good for doing 3D carving. As you can see right here, it's carving the hops flower. And it actually looks pretty good. You can see once we got the carving done, it's a good looking 3D carve. And it doesn't really have a lot of detail, but there's enough detail to see that it's 3D carved. And that is done with this bit right here, the 1/8 ball nose end mill. So these are good bits to use. Now, I want to describe a different bit that you can confuse as a ball nose, and that is this one here. This is a bowl and tray bit. Now, the difference of the bowl and tray is this has a radius, but it's not completely rounded. It's flat on the bottom for a little bit. So this is a 1 inch bowl and tray bit. So it's a 3/8 inch radius, and then there's a flat right here. And these are good for your bowls and your trays. So it's called a bowl bit or a tray bit, generally a bowl and tray bit. Now we've learned about the ball nose, we've learned about the bowl and tray bit, and you know about the bull nose. The next one is one that you're really going to like. And that is the taper ball nose bit. Now, these are the guys that do the real fine detail 3D carving. So the thing with taper ball nose bits is they are tapered, as you can see, but they have a radius on the end. And the radius can be different for different taper ball nose. For IDC Woodcraft, we have the fine detail taper ball nose and the ultra fine detail taper ball nose. This for your standard 3D carvings. And then we have the fine detail taper ball nose and ultra fine taper ball nose, the long ones. The difference you're gonna see is the angle. So this is what we call a 10-degree half angle, or it's 20 degrees like that. This is a 6-degree half angle or 12 degrees like that. This half angle distinction is really, really important when you go to plug your taper ball nose bits into your router bit database in your software, because the software is going to calculate based off the angle that it is asking for. So in the case of the Vectric design software, which is what I use, it is going to ask for a half angle. So a half angle is essentially, here's the bit, and then there's the taper, and there's a radius at the bottom for this taper ball nose. So we have the center axis going down the bit. The half angle is half of the whole angle. This whole angle here on the 10-degree taper ball nose from IDC Woodcraft is actually 20 degrees all the way across there. But the Vectric design software refers to the half angle. And so the half angle is 10 degrees. And why do we use the half angle? That's pretty standard in the design software because it's basing all its calculations off of that half angle. So the taper ball nose can do really, really cool 3D carves. As you can see, some of the 3D carvings I've done here, like this wizard and this rendering of me. I loaded an image into an AI program that generates 3D models, and it turned out a really cool image of me. And these are good for all kinds of 3D projects, and these are the ones that you definitely want to get in your arsenal, especially if you want to do 3D carves. And I don't know anybody that doesn't want to do 3D carves. Another bit that you will seriously want to consider as you're building up your CNC router bit arsenal is the roundover bit. This is the one that's going to really take your projects over the edge to add the elegance to them and make them look a lot more professional. The roundover bit looks just like this. So it has that rounded edge on it, and then it steps away. It's got a little point on it. This is a 1/4 inch roundover bit, so it has a 1/4 inch radius on it. And then this one's the 1/8 inch roundover bit, it has an 1/8 inch radius on it. And this is the one that is going to make a project that looks like this game board that I made for my niece. It actually didn't stain very well, so I had to make another one. But it's what's adding the edge, the rounded edge, all the way around the project. As you can see, it's cutting right here. In this video, it's actually cutting this project. And then for this card holder, these are slots for the cards, the 1/8 came in and just rounded up all these edges here. So it all got rounded out very nicely. And I used the 1/8 roundover bit on this cribbage board here. So the entire edge is rounded over by the 1/8 roundover bit, and it just takes it to another level. So the roundover bits are really, really good to have. Now, since we're talking about the cribbage board, I want to tell you about one more bit. So we got 2 more bits to cover, this one here and then one more. So when it comes to cribbage boards, if you want to make a cribbage board, drilling these holes takes a long time. So you want to get a drill bit that's specifically designed for CNC routers, for the high speeds of CNC routers. So if you get an Endmill, which can drill, it takes a lot longer because you have to peck. But when you have a bit like this is a specifically designed by me to work very quickly on the cribbage board to get these holes drilled, because you can imagine how long that would take. So you can see here in this footage, it's drilling really fast, each one of these holes. So that's why a drill is really important to put in your arsenal if you want to make something like this. And the final bit is what we call a drag bit. Now there's several types of drag bits, but we're just going to cover the diamond drag bit. So a drag bit, the bit does not spin in the tool. The spindle is actually turned off, and the bit just drags across the material. So this is a diamond drag bit, so there's a very fine diamond point on it. And these are excellent for engraving on acrylic. This one here can engrave steel, granite, glass. So this is an industrial grade engraving bit, a drag bit that's made by Widget Works. We carry these at IDC Woodcraft. So that's that's a really nice tool if you want to get into the lighted LED signs. And those are all the core CNC router bits that you will end up working with in your CNC journey on a regular basis. And one other real quick is the keyhole cutter. This is the one that is going to cut the little hanging slots in the back of your projects. So when it comes to CNC bits as a brand new beginner, trying to figure out what you need to get going is kind of hard. So that's why at IDC Woodcraft, we put together starter sets for you that you'll be set up with that set. We have 3 sets. We have the basic set, that's the economy set. And that's going to contain the basic bits that you absolutely have to have. The surfacing bit, the 1/4 inch down cutter, 1/8 inch down cutter, 60-degree V bit, and a 90-degree V bit, and then a 1/8 up cutter. If you're on a budget, that's the one you want. Then we have the only truly complete CNC router bit starter set. This is a set that I put together because most of the companies out there come out with these 5-piece sets, and that's not enough to get the projects going that you are going to want to do. This is an 11-piece set that contains all the bits we just covered in the basic set. Plus, we have the 30-degree extreme detail V-bit, the 16th downcut end mill for really fine detail work, and then the 1/4 inch ball nose end mill and the 1/8 inch ball nose end mill. So this set really expands your capability as a CNC beginner. But if you really just want to jump all in, we have the all-in pro set, which is a 20-piece set, and it includes a set of calipers. You can see it here. There's a lot of CNC router bits, and it includes the tapered ball nose bit. And if you use that code that I've given you right here, then you will get the 10% off of your set. You want to just start off with the set, right? Don't try to figure it out. As a brand new beginner, our CNC router bit companies, we got sets put together. So I've linked those down below in the description. I definitely suggest you go check them out and use that discount code I've given you here. It's a one-time use discount code, and that will get you 10% off of those of those sets and any CNC router bits you get from IDC Woodcraft. My friend, you have just learned all the basics about CNC router, and you are no longer an absolute green beginner. You now understand the basics of the machines. You know what you're looking for in a machine. You know about the design software and toolpaths, the control software, and the CNC bits, and the important aspects about CNC routers. With that, I'm going to check out. We've been together for a long time. I need to get a break here. So you, my friend, if you got something out of this, then give me that thumbs up. And I'll catch you in the next CNC video. Have an awesome day. IDCwoodcraft.com